Hello everyone, good evening.
Good evening, sir.
Good evening, sir.
Good evening, sir.
Good evening, sir.
Okay, so today we have revision session for week 9 and 10. So let's begin with it. So for now, I'm assuming that you all are clear with the concepts of week 1 to 8. Because from week 9 to 12, we will be doing the same things mostly just by using random variables. We will discuss it today what actually a random variable is. And then the probability questions which you did already in week 7 and week 8, we will try to solve similar pattern questions using random variables and try to simplify the problems by using some distributions which are covered in week 11 and 12. Okay. So have you all covered the week 11-12 content also?
Sir,
Yes, sir.
hello.
Yeah.
Yeah, sir. I'm not able to figure out answers for 2 questions in week 9. So I just have those 2 doubts in week 9 and no more doubts.
Okay. So yeah, we will begin with first the concept discussion of week 9
Yeah,
and then
after the concepts, can I ask you them?
yeah, sure.
Okay, thank you.
Okay, so before starting, do you all know what actually an experiment is? What is an experiment? Anyone?
Yeah, sir. Any process that produces an outcome is an experiment.
Okay, great. So any process that produces an outcome is experiment as per you. Okay. Anyone, anything else? Or you agree with him?
Same, sir.
We cannot predict, sir.
Yeah, that
Predict
is random
outcomes.
experiment.
Yeah.
No. What is an experiment? In general, what is an experiment? We will
It's a
move.
trial.
Yeah. So in generally, we perform something and we note down its outcome. It's generally referred to as some experiment. Like those who have done 11, 12 in science might have done some experiment in chemistry labs. And I think commerce students also do some in accounts or something, right? So all your practicals you can assume to be an experiment, right? You do something, you observe it, and then write it down, right?
Yes, sir.
So in general, we can classify our experiment into 2 categories. One is random experiment. Another one is deterministic experiment. So yeah, this might be a new term for you, but yeah, it's
Yeah,
just
it's in the week zero notes, sir.
yeah, it's in week 0 notes. Yeah, deterministic experiment is something whose outcome is fixed. Okay, suppose suppose you're driving a car at the speed of 50 kilometer per hour. Okay, starting from this point A, and after 4 hours, suppose you are at point B. So the distance you covered in this 4 hours, it will always be 200 kilometers.
15, yeah.
It's 200.
So the outcome for this experiment will always be fixed. If a person A do this, he will also get the same result. Person B do it, he will also get the same result, right? So every time, anytime you repeat this experiment, you will get same outcomes, right?
Yes, sir.
In case of random experiment, what happens is we don't know what actually would be the outcome, right? Suppose we are tossing a coin. We don't know what would be the outcome, right? It could be either head or tail, right? But what we do know is that it is gonna be one of these. It will either be head or tail.
In a
So
random experiment, we can basically find the probabilities of different cases, but we don't know what might happen exactly.
yeah, so the basic condition for random experiment is you don't know what actually is the outcome of experiment, but you know that it would be one of these only, right? If we are rolling a die, I don't know what would be the outcome, but what I know is that it would be one of these only, right? No other outcome is possible except these 6 outcomes, right?
Exactly.
So these such experiments are called random experiment. Everyone clear with what actually a random experiment is?
Yes, sir.
Okay, let's move forward. Okay, so for now, the term which I'm using is that we know what all possible outcomes could be. It would be like for tossing a coin, it would be either head or tail, no other possibility. For rolling a die, it would be any of these numbers from 1 to 6, right? So these sets is nothing but our sample space, right? Sample space of the experiment. Whenever you perform experiment, you will get one of these outcomes only. The set of all possible outcomes is sample space, right?
Yes, sir.
So, okay.
Is one of the conditions that the sample space has to be finite?
Not necessarily. It could be infinite as well. It is possible to have infinite. Okay. Suppose, uh, suppose, uh, suppose this is a road, okay, and
Okay.
you are, let's say, you have fixed this point, okay. So you will notice, like, note down how many number of cars passes through this point on the road, okay. So it could be either 0 cars, 1 car, 2 cars, right, 3 cars. It can go up to infinity, right?
Great. Yeah. Okay.
Not necessarily be finite always.
Okay.
Okay, so moving further is okay. So random variables. So random variables is actually gonna make your life a very simpler in solving problems. So what we actually do in random variables is, suppose we are tossing 2 coins. So our possible outcomes would be head head, head tail, tail head, or tail tail. So what happens actually, suppose my interest is in knowing what the number of heads I am getting. Okay. So in this case, we are getting 2 heads. In this case, I'm getting 1 head. In this case, also I'm getting 1 head. In this case, also I'm getting 0 heads. So what I can do is I can assign these real values to each of the element of the sample space. So suppose X is my random variable. And as per my interest, I can assign values to each of the outcomes. Suppose I wanted to count number of heads, then I'm tossing 2 fair coins. So in that case, I can assign value 2 to the outcome HH, value 1 to outcome HT and TH, and value 0 to TT. Suppose now your matter of interest is number of tails. In that case, you can assign different values to random variable, right? In that case, you will assign 0 to this outcome, 1 to these 2, and 2 to tail outcome, right? Another possible way could be, suppose you are in a gambling game, okay, and the game says that you will get a benefit of plus $5 if you get ahead, and you will lose $3 if you get a tail. Okay, so in that case, my matter of interest
Plus
is
5 minus 5. plus 5 minus 3, right? Variables.
No, I will get +5 if outcome is head. Based on number of heads I'm getting, if I get one head, I will get $5. If I get two head, I will get $10.
Okay, it's the equation we applied to it.
So if I get a tail, I will lose $3. So for this interest, you can assign different values to random variable, right? So for two heads, you will gain $10, right? So you can assign value 10 to this. For head tail, you will get a benefit of $2 because you get 5 for getting head and lose 3 for getting tail. Similarly, tail head again, you will get 2, and for tail tail, you will lose 6. So based on our interest, we can assign these values to random variable. So random variable, actually, what it does is it assigns a real value, real number value to each of the possible outcomes or each of the element in my sample space.
So
Is it-
we may have negative values also, sir.
Yeah, you can have any value. You can put any value based on your interest. It is possible to have all negative value as well.
That's right.
Sir, this 0, 1, 1, 2 is number of heads or tails, sir, in the above?
It is number of tails.
Tails, okay.
So yeah, based on your interest, the value keeps on changing, right? You can assign it as per your interest, right?
Okay, then no, sir, I have little confusion. In PMF only, then we shouldn't have, it should be greater than or equal to 0. We shouldn't have less than 0 X values.
No, you can have less than 0. You can have it. There's no problem in having.
But according to PMF properties, it should be greater than or equal to 0. No, so the value of X.
It's the probability of the values of X.
Oh, probability of X. Okay, sir.
We'll come to that part also. Is this
Okay, sir. So now, as of now, we will have random variables as negative.
so you
Okay,
understand what actually is random experiment and what is the role of random variable over here? Is this thing clear till now?
Yes, sir. Yes, sir.
Okay. Okay, let's move further. Okay. So do you all know what is discrete and what is continuous variable? We covered in week 1.
Yes, sir.
So same.
Discrete is, you
Yeah.
gave the
Which is
definition also that
countable.
which is countable is discrete, which is
Discrete.
measurable is continuous.
Suppose your x is
Continuous, there can be any value between two numbers.
so your x is a random variable, okay? And in general, you can classify, since it is a variable, you can again classify it into discrete and continuous, like we did in week 1, right? So how would we classify it into discrete and continuous? So
If it assumes countable values, then it is discrete. If it assumes values between two in between an interval, then it is continuous.
so discrete and continuous, it depends basically on what values our random variable is taking. Okay, suppose our random variable is taking values 0, 1, and 2. Will it be discrete or continuous?
Discrete.
Discrete, right? And suppose I have to, let's say, measure an area of room. Okay, so suppose there is an apartment
12.5.
which rooms of different size, and we know that the possible values could be in between 400 square meter to 600 square meter. So in general, my random variable x can take any value in between 400 and 600. So will it be continuous or discrete? Continuous, right? Because it can take any value within this interval, while here in this experiment, it can take only some countable values. It will not take all the values in between the two numbers as well, right? It will either take 0 or 1 or 2. It cannot take any value like 0.5, 0.75, no in between values, right? So discrete and continuous variable, the same thing applies to discrete random variable and continuous random variable. If you're clear with that week 1 concept, this thing It's pretty easy to understand, right?
Sir, even if it's the range is not given, then the area is anyway a continuous variable, no?
Yeah, area is anyway continuous variable, but for random variable, you need to see what all possibles your random variable can take. Okay, suppose this is okay. You are saying area, right?
Area or weight.
Suppose I can modify my random variable based on my interest, right? So suppose I am putting some prices over here. So let's say if the area is between 400 to 420, I will sell it for, let's say, some 10 lakh or something. Okay. If the area is between 420 to 440, I will sell it for 12 lakh. 440 to 460, I will sell it for 16 lakh. If it's between 460 to 500, I will sell it for, let's say, 20 lakhs. So see, now I have changed my random variable. Right here, the random variable is the fixed prices, fixed value it can take either 10 lakh, 12 lakh, 14, 12, 16, or 20, right? Even though it is in terms of area, it's discrete now, right?
Yes, now that's because now we're considering the rupees, the X.
Yeah, but rupees is also a continuous random variable if you look in general.
Yeah.
But here it depends on what values your random variable are taking. So you need to be careful while identifying which discrete or continuous. Just look at the possible.
Not just generalizing on the.
Yeah, you can't generalize. You have to look at all possible values.
Yes.
Okay. Is this thing clear, everyone?
Sir, so here it is discrete, isn't it, sir?
Yeah, for this case, it will be discrete because it can take only
It
these
takes values. Yeah.
only
right.
4 possible values.
Yes,
Right?
sir. Understood.
Sir, is it possible
Sir,
for
what is
random variable to
deterministic?
be,
One by one. Yeah.
sir, is it possible for random variable to be both discrete and continuous? Some value taking discrete
Yeah, it
value.
is possible, but it is beyond the scope of this course for now.
Okay.
It is possible. Such variables we called as mixed random variables. So what, okay, just to give you an idea what happens, it is possible that it will take values 0, 1, 2, and then it will take some values in the interval 3 to 10. And then it can take some values 12, 13. So in real life, yeah, we do have mixed random variable, but it is beyond the scope of this course for now. So we will not go into this thing for now. Okay. But yeah, it is possible to have both discrete and continuous. Okay. Is this thing clear, everyone, or any doubt till now?
Sir?
Yeah.
Sir, in case of discrete, the values can be fractional, right?
Yeah, it can be. It can also be possible to have these values. See, what happens in discrete actually is you are jumping from one value to another. It doesn't matter which value. Okay, suppose this is your number line. Okay, you are at this point. So you are jumping to another value in general. After this value, you can only take this value. These in between values you cannot take, right? While in continuous, what happens is you can take all the values within this interval. While in case of discrete, it's kind of jump thing you can see. You are jumping from one value to another. You can't take in between values in the jump. Is it clear?
Yes, sir.
Yes, sir.
Anyone?
Sir,
On it? What is
Deterministic.
deterministic? It's not a variable because it is fixed that we know that this is gonna be result. If I drove a car for 4 hours at 50 km/h speed, I know I'm gonna cover 200 kilometers only. It's fixed. It's not a variable at all, right? It's a fixed value we will get. So deterministic experiment are those in which we know what would be my final outcome. While in random experiment, we don't know what will be my outcome, but I know, yeah, it's gonna be one of these values. So to we assign the real numbers to each of these possible outcomes and we name it as random variable, that it can take these. Its values keeps on varying. But in deterministic, we have some fixed values, right? Okay. Is it clear or any doubt till now, anyone?
No, sir, clear.
Clear, sir.
Okay. Okay, so now we know what is random experiment. We now know what is random variable. Okay. So let's move to PMF. Okay, so PMF is only for discrete random variable. Okay. Its full form is probability mass function. While for continuous random variable, it becomes EDF, which is probability density function. Okay. So let's focus on PMF for today, at least week 9 and 10, because you will cover this PDF in week 12. So let's not go into that for now. So, okay. So suppose we have done some random experiments, right? And let's say tossing 2 coins. So my sample space was head, 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 tail, tail, head, and tail, tail. And let's suppose it's not a fair coin. So we have probability of head to be, let's say, 0.3. And probability of tail would be 0.7 automatically, right? Okay. So suppose my interest is in counting the number of heads I am having. So I can assign my random variable some values based on it. So for first outcome, it would be 2, 1, 1, and 0 over here, right? Now, if I assign probabilities to each of the possible values of random variable. Okay, so what all possible values my random variable has?
0, 1, 2.
0, 1, 2, right? So if I assign it the probability such that each of the assigned probability is either greater than or equal to 0. Okay. And secondly, if I sum all the probabilities, like in this case, if I add the probability for x equals 0, x equals 1, and s equal 2, I should get 1. So if you notice, these are just the general condition of probabilities as well. That your probability cannot be in negative. So it must be greater than or equal to 0, right? Second property, if you notice, your random variable takes, like your random variable is all the possible outcomes in the sample space only, right? So you have already assigned all the elements of sample space some real number. So if you add up the probability for all of this, you should definitely get 1, right? Because we know that probability of sample space is equal to 1. So it's just a different way of writing. In general, these are the properties of probability that we studied in week 7. Is this thing clear?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Okay, so moving forward. Okay, so now let's
Sir,
start.
one small doubt, sir. I checked in Solve with us week 9, sir, today, and
Okay.
I found one question. If P of x is equal to x is equal to x by 16, where x takes value 4, 5, minus 1, and 8, sir. Is it PMF or not, sir?
It's not.
Why, sir? Because of minus 1? Because x takes minus.
No, it's not because x takes minus 1. See, the question given is this, right?
X by 16, sir.
Okay.
Yeah.
If I
Where
take
x is
Yeah.
4, 5,
minus 1 and something else, right?
yeah, minus 1 and 8.
If I take minus 1, what would be
Yes,
my
sir.
probability?
Minus 1 by 16.
Is my first condition violated?
Okay, sir. Okay.
Clear now?
Yes, sir. Yes, sir.
So for PMF,
I just randomly checked X. Okay, sir.
okay, so you need,
Thank you, sir.
while defining PMF, you need to take care of these two conditions. These are
Yeah.
a basic probability condition, just written in terms of random variable only, nothing else. It's the same thing you studied in week 7. Okay.
Okay, sir. Thank you, sir.
Okay, moving further, so for x equal to 0, when will your random variable x will take value 0? When you get both the tails, right? So its probability would be getting tail in the getting tail in the first, getting tail in the second, right? Assume we are tossing independently, like each outcome is independent of other. So it's 0.49. Okay. For x equals 2, for x equal to, I should get both the heads, right? Only then my random variable x will take value 2, right? So its probability would be 0.3 into 0.3. Clear till this step? Everyone?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Okay, moving further, you have to find the probability when your random variable x takes value 1. So here notice it takes value 1 in 2 of the outcomes, right? So if I get this outcome or this outcome, my random variable is gonna be x equal to 1 only, right? So I need to add a probability for both the outcome, because if either of it happens, I'm gonna get x equals 1, right? So for at tail, it would be 0.7 times 0.3, right? And for tail heads, it's gonna be 0.3 times 0.7. If you add these two, you will get 0.4. So we have computed the probabilities using week 8 concept of independence for now, right? Let's verify if it is satisfying our PMF conditions. So each of the probabilities greater than or equal to 0, right? First condition is satisfied. For second condition, you need to add up all the probabilities for all the possible values of x. So these are the 3 possible values of x, and if you add up the probabilities, you will get 1, right? So both of the conditions are satisfied. And this is called, this table in general is called probability mass function, where you have the values which x can take and long, and the another column you have the respective probability of random variable x taking that value. Is it clear? Or any doubt in it?
No, sir, clear.
Okay. Suppose let's consider our another random variable which we take, like I will get plus $5 if I'm getting head, right? And I will get -3, I will lose $3 if I get tail, right? So in that case, the possible values for x would be 10, right? Or in case of head, tail, and tail head, it would be 2 and -6, right? And probabilities, x will take the value 10 if I get both the heads, right? So it's again 0.49. X will take the value 2 if I get either head, tail, or tail head. So it would be 0.42 again, and x will take the value -6 if I get both the tails. 0.09. So it is possible for random variable x to have negative values. Okay, and you will notice that here also the properties of PMF are still satisfied. It adds up to 1, and each of them is greater than or equal to 0.
Okay, sir.
So yeah, is this clear to everyone till now, or any doubt?
Yes, sir.
Yes, sir. No doubt.
Okay, let's, yes. Similarly, let's into it, but you can plot the graph for it as well. So you are, for visualization purpose, it will be helpful in stats too. Yeah,
A step graph.
can plot it. So suppose I'm doing it for this table for now, for this one. So x can take the possible values 0, 1, and 2.
It's a step graph, right, sir?
Sorry, can you repeat?
It's a step graph, now.
Yeah, no, not step graph. It's PMF we are plotting.
Yeah, we are plotting that, but it's like we draw steps, like it's called a type of a graph, right?
Yeah, that's for CDF. We will come to that as well.
Okay.
For PMF, you generally plot simple bar
The
graph.
bar graph or scatter plot, yeah.
So for 0, it will be something 0.49, right? And for 1, it gets reduced to 0.42. And for 2, it's pretty small, 0.09, right? So you can plot this graph for the PMS also. Is it clear till now?
Yes, sir.
Yes, sir.
Okay. So depending on the graph, you can also tell the skewness. Okay. Does anyone of you know what is skewness?
Yes, sir. If the graph is left skewed, it will go to the left. It will rise up to the left. Sorry, rise up to the right.
It will be in one particular direction, whether it is ascending or depending on whether it is ascending or descending. Or sometimes even distorted if the middle value is the highest.
So it is a symmetric graph. When the probability of the peak one is to the left hand side, the skewness is to the left, and when the probability is to the right hand side of the peak one, the skewness is to the right.
Okay. Okay, let me ask a few questions then. Next one could be this one. Yes, I have randomly plotted some plots. Okay, so here in the first plot, let me number it. First plot, second. Okay. So if you notice in the first plot, so here the longest bar, you can see it's kind of centralized, right? It's in the middle, right?
Yes, it's right.
If you notice it's something, it's in the middle only, right?
It's symmetric.
So such plots are called symmetric. So what skewness does is, skewness gives you a measurement of asymmetric, like how much your plot is not symmetric. So it has some coefficients to compute, which is for now beyond the scope of this course again. But you should have an idea that skewness tells you about the symmetricity of the plots. So here, if you notice that your longest bar is shifted to the left side, right? It is, this plot is something going like this, right? You have a long tail on the right side of the plot, right? This.
Yes, sir.
So whenever you are having long tail on the right hand side, it is called right skewed, or some books use the notation positively skewed. Okay? Because yes, it means your longest bar is shifted to the left hand side of the center. Because in general, your center should be this, right? This one should be your center, but it has shifted to left hand side. So it is called right skewed or positively skewed. Okay, moving here you can see that it has shifted to the right side of the center, right? In general, it should have been here, but it has shifted to the right side, and you have a long tail in the left side. So it is called left skewed. Is this clear, everyone, or any doubt?
Yes.
Sir, which type of graph here will present the most meaningful information?
Meaningful information, like, see, all graphs are giving you meaningful information. It's just a measure of whether, whenever you are going into doing some analysis, you should be aware of whether your graph is symmetric or not. If it's not symmetric, you cannot perform some operations. So skewness gives you an idea of it, whether it's symmetric or not.
So does the skewness also give idea about mean, median, and mode?
Yeah, it does give. It will give you. So
How,
here,
sir?
your mode has shifted to the left hand side, right?
Yeah.
In right skewed graph, you can see that your mode has shifted to the left hand side, the longest plot,
Yes, sir.
right? While if you notice that median, okay, let me show it. Okay, here you see this center point symmetric graph. You have always mean equals median equals mode. Okay, with those who don't know, let's not worry about it. It's way beyond the scope of this course for now, but just for information. So here you see in positive skewed, your mode has shifted here, right? But your median would still be the center, right? And in positively skewed, it is known that mean would also be somewhat on the right side of the median. Okay. While if you see in the left skewed, your mode has shifted over here, right? And your median will again be still the center one, right? And your mean shift to the left side. So that's how mean, median, mode get affected.
It means the mean shifts to the tail.
Yeah.
Inside.
Yeah. Median always remain the center. Mode and median shifts as per the symmetricity of the graph.
Okay. Thanks.
Okay. Anyone any doubt till now? Before you move to last.
Mode median means what?
Can you repeat?
Sir, here mode and median means what?
Mode and median means if you find the mode and median for that random variables we are doing for the distributions. We will cover that. We will cover mainly it in stats too for now. It's just to give you an idea of it. You will know how we compute these values as well. Mean is nothing but the expected value, which you will cover in that week 10 for now. Okay.
Okay, sir.
Okay. So you're clear with the basic raw idea. Is it clear to you how symmetricity is affecting your measures of central tendency? Mean, median, mode, right?
Yes, sir.
Anyone any doubt till now before we proceed further?
No, sir.
No, sir.
So in one of the questions in activity, there was I marked it as right spin because I got the probability at the random at some random variables from.
Which one are you referring to? Which activity question, week 9?
Actually, it is from week 11.
Week 11. Okay, we will come to that after week 9, 10. Let's focus on week 9.
Can you also plot the graph of a PDF afterwards?
PDF, yeah, we can do that. For in week 11, week 12, we will do the plotting for PDF as well.
Yeah. That only if at the last you get some time.
Yeah, we will do. Okay, moving further. Okay, so next concept is CDF, also called cumulative distribution function, right? Okay. So what actually is CDF? Okay. So in general, it is represented by capital F. Okay. And it take input some value. Suppose it takes the value X as an output, or what this symbol actually means, it is the probability that your random variable X, let's make it constant A for now, that your random variable X will take the value less than or equal to this value A. So this capital F function is called cumulative distribution function, or in short, we refer to as CDF. What it means is what is the probability that your random variable X will take the value less than or equal to the constant A over here. Is it clear? So let's suppose your random variable X take possible values. Okay, let's assume it to be a PMF. No. Let's see, random variable takes value -2, -1, 0, and
So like if f of a will always mean like x is less than or equal to a, probability of less than equal to a.
always, yeah.
Okay.
Okay, so let's assume this is your PMF. Okay, plug in some random values. So, and suppose I asked you to find the cumulative distribution function, or capital F of 3. So what it actually means is probability that your random variable X takes value less than or equal to 3, right? So if you notice, what all values are less than or equal to 3 for your random variable? So this value, -2, -1, and 0, right? So 5 won't be here because it is greater than 3. So you can write it as probability that your X takes the value -2 plus probability X takes the value -1 plus the value 0. Is it clear? You can simply add them up. What other ways you can modify it? There would be simpler way to solve it. Like here, if you notice, I need to add three probabilities. It's gonna definitely take some time, right? So how can we reduce this time?
1 minus
Yeah.
probability of 5. X greater than 3.
Greater than 3.
Yeah. So we know that sum of all the probabilities would be equal to 1, right? So what I can do is I can write it like this: 1 minus the other left out region, right? Which is greater than 3. So in general, we can write it as 1 minus probability. Greater than 3, we only have one value, right? So it's definitely going to reduce our computation over here. Right? So which is nothing but 1 minus 0.30. And you notice that you still get the same answer. So another, you can either use this, or depending on your need or whatever you feel will save the time for you. This is your CDF. Is it clear, everyone?
Yes, sir.
Sir, in the third step, you were supposed to write 4, right? The one you've written in green.
No, it's 5, right? This is our PMF. It takes the value -2, -1, 0, and 5. So for greater than 3, we will only have one value 5 possible for random variable X.
Sir, are we counting them or are we writing the value of the random variable?
So here what it means is all those values of random variable which are greater than 3. So random variable X cannot take the value 4, right? It can only take value -2, -1, 0, and 5. So only value which is greater than 3 is 5, right?
So
Like-
3 refers to 0, right?
Which, like, can you elaborate? Like, but
So P of x lesser than or equal to 3.
yeah.
So it's all the values that's less than 0, right?
No,
So
no,
minus
Less than
2's
equal to
value.
0. Less than equal to 0 according to probability addition.
because here, if you notice, your possible values for x are -2, -1, 0, and 5, right? So when I'm saying all those values of my random variable x which are less than equal to 3, yeah, it is only these 3 values, right? So we added them up. And while we move to green part, we are talking about all those values which are greater than 3. So it is only one value, 5, right?
Sir, what is probability x equals to 3? It's
0.
0.35.
No, x equals 3 is 0, right?
No, probability x equal to 3.
Yeah, because your random variable cannot take the value 3, right? Your random variable can only take value -2, -1, 0, and 5, right? 3 is not even a possibility. So x equal to 3 will never happen. So it's an like uncertain event to ever happen.
Like probability of x is less than equal to 3 is equivalent to probability x less than equal to 0 according to the
Okay.
function.
Yeah,
Okay.
according to the function it is. In other words, okay, see, what does x less than equal to 3 means? Probability x equals 3 plus probability x equals 2 plus probability x equals 1 and plus these 3 values, right? So here you notice, when will your random variable x be equal to 3? Like, what are the chances of x being equal to 3?
For 3, 2, and 1, it's 0.
0, right? Because my random variable x cannot take value 3 in it for any of the outcome. So it will never happen in general. So probability for x taking value 3 is 0. For x equal to 2, again, it is not possible for my random variable x to take value 2. So it's again 0. X equal to 1, it's again 0 because it cannot happen. For x equal to 0, yeah, it can take the value 0 with probability 0.35. For -1, yeah, it is also possible with probability 0.25. For -2, yes, again possible with probability 0.10. Is it clear now? Or
The
any
probability x equal to 3, you've assigned the value of probability of x as 0, right? From the distribution.
probability x equal to 3?
Refers to 0.35.
No, it don't refer to 0.35.
No, probability x equal to 3 doesn't exist. So that's why we have given a value 0 to it. That's it. Simple.
Your x cannot have value 3, right? How will you get its probability if it cannot take value 3 ever? It's like you are tossing a coin. Can you get a number 6 on it?
It's
only,
like she's thinking the number 3 to be the third term of the random variable. Actually, it's just a number is a random variable we are comparing it with.
yeah.
She might be thinking it that way. I'm just saying.
Yeah, sir, I am thinking it as like a counting thing.
No, it's not the term-wise thing. It's literally meaning the random variable should be less than or equal to 3, and which is -2, -1, and 0, but not 5. So literally.
Okay, I got it.
Yeah.
Anyone, any other doubt in this? Shall we move forward? Okay, let's move forward then. So now we are clear with that CDF function, right? Let's move to its properties for now. So it has only one basic property. Okay. Firstly, what is the maximum value of CDF? That it
1.
can 1, right? Its max value can be 1. It can never exceed 1. Why? Because let's say I say probability, okay, let's say f of 6. It means probability that my random variable x will take the value less than or equal to 6, which is nothing but all these 4, right? If I add these 4, I will get the probability of 1. Whatever number you take, it will never exceed 1, right?
Generally, any probability cannot be greater than 1.
Yeah. Another from properties of probability, you know that it's gonna be in between 0 and 1 only. Because CDF is nothing in general, at the last it's a probability only, right? So it will satisfy the properties of probability and it will lie in between 0 and 1, both included. Okay. Another yeah.
Will you take any question which will include converting probability mass function values into cumulative distributive functions?
Yeah, I'm coming to that as well.
Yeah, okay. So.
CDF to convert PDF.
Okay, further. Okay, so yeah, another thing to keep in mind. Suppose I have two numbers, let's say A and B, such that A is greater than B. Okay, so in that case, my cumulative distribution function with input as A or capital F of A would always be greater than or equal to F of B. That's the one thing you need to keep in mind. As the value of your constant keeps on increasing, it will never decrease. It will either remain the same or it will increase. Okay, let's see it using this table. So here, suppose my A equals 0, okay, and B equals, let's say, -1. Since my A is greater than B, right? So my F of A should be greater than or equal to F of B. Right? So what is my F of A? F of A would be all probability that my random variable takes value less than or equal to 0, which is nothing but the sum of these three, right? 0.70. While F of B, it is my random variable x takes all the values which are less than or equal to -1, so which is nothing but the sum of only these two, so it's 0.35. So you see that it is, if A is greater than B, my F of A will always be greater than or equal to B. So in what case will it be equal to? Okay, let's say.
So generally, we can say if A is greater than B, like we can say the CDF of A is like probability of B plus A, and B is just probability of B. Yeah, no?
Yeah.
Thank you.
Suppose my A is equals to 5 and B is equal to 6. So in that case, my F of A would be probability x less than equal to 5, which means all the possible values of x, right? So probability would be 1. And if my B
would be same,
it will also be same. So you see that it will not always be greater than, it can be equal to, but in any case, it won't be less. If A is greater than B, my F of A cannot be less than B, F of B. Okay. This is one basic property of CDF you need to keep in mind. Any doubt till this point, anyone?
If B is minus 0.5 and A is -1, still it will be equal, right?
Yeah, still it will be equal.
Sir, one question over here. In the case where you said it would be equal,
yeah,
is it necessary that always the x value should be greater than the acceptable range of values that it generally takes?
Let's say my A is minus, okay, let's say my A is 0, okay, and B is 0.5.
Okay.
In that case, probability x less than equal to 0, it means first three values you need to add, right?
Yes.
Here also first three values you need to add, right? It will be same.
Got you. Thank you. Thank you.
There will be cases when it would be same. Anyone, any other doubt in this? Shall you proceed further? Okay. So when you plot the CDF, it comes out to be a special kind of graph. We say it as step function. So what happens in it? Okay, let's try to visualize it a bit. Okay. So my x can take possible values -2, -1, then 0, and then 5 over here, right? Okay, let's draw. So what would be my CDF for all those values less than 2? Let's say -2.5. So what would be the CDF of -2.5?
0.
0, right? Because all those values which my random variable takes less than equal to -2.5, not possible, right? 0. So it will stay 0 till here, right? But as soon as I reaches -2 point, what is the CDF of f of -2?
-0.10.
0.10, right? Because it means probability x less than or equal to -2, which is nothing but probability my random variable x taking value -2, right? So as soon as we reaches 2, it will go up by 0.10, right? And then in between -2 and -1, any value you take, it will remain 0.1, right? Suppose we take -1.5. What would be the CDF of -1.5? All those values which are, yeah. Again, it would be probability x equals -2, which is nothing but 0.10. So till -1, it will stay 0.10. But as soon as we reaches -1, it will take a jump of 0.25, right? Because f of -1 is nothing but 0.10 plus 0.25, right? And then in between -1 and 0, any value you take, it will stay the same, right? Similarly, at 0, it will take some jump of 0.35, and it will stay the same till we reach 0.5. And after reaching the 0.5, it will become 1, and you take any value greater than and you take any value greater than 5, it will remain 1 forever. Is this plot clear to everyone?
So here the hollow circle denotes that it is not, you have drawn hollow circles and darkened circles.
Yeah.
So 0 for 0 it is 0.7. So the darkened circle it has 0.7 and the hollow circle is at 0.35, right?
Yeah. So hollow circle means at
it
point,
is not the probability.
It will not take this value. It will take this.
Yes.
At 5, it will not take this value.
Yeah. Hollow means the graph is discontinuous there.
Yeah, discontinuous at all the points. It will be discontinuous at -2, then -1, then 0, and at 5 also.
This dotted line actually is not in the graph. This dotted line should not be there. It is just a step function.
Yeah, dotted lines, you can draw, it's up to you. It's just to show that there is a discontinuity.
Okay.
So you visualize that it is some kind of a staircase, right? We are going step by step.
Step function.
That's why it's called step function.
Sir, it is always be increasing now.
Yeah, that's what we said, right? This property. It will never decrease. It will either remain the same or increase, but it will never decrease at any point, right?
Sir, but we are converting this discrete into continuous variable, and then we are going for cumulative distribution function.
what we are doing, we are converting discrete to.
We are actually converting it to discrete. From discrete to we are going to continuous because there is a gap between 0 and 1. And continuous also tells that from 0 to 1.
Is continuous. You can take any value in between. So you can assume it to be like this. Okay. Any doubt till now, anyone, before we proceed further?
Sir, can you explain this graph again?
Okay. Okay. So do you understand this, that if you take any value less than -2, this CDF function will take the value 0, right?
Yes, sir.
Because any value less than 2, you can assume it to be even -2.1. So f of -2.1 means the probability that my random variable x takes value less than or equal to -2.1, which is not possible, right? Because the minimum value my random variable takes is -2. So it will remain 0
Yes,
for all
sir.
the values less than -2, right? But as soon as we touch the -2, my probability will be like f of -2 would be 0.10, right? F of 2 in general, if you look, it's nothing but probability your random variable x takes value less than equal to -2, right? It is nothing but only possibility is this, right? -2.
Yes.
So we got a jump of 0.10. So now if you take any value in between -2 and -1, your f of a would remain 0.10, right? Even if you take f of -1.5, it will still be 0.10, right?
Because we take less than or equal to the.
See, if I take f of -1.5, what would it be? Probability that my random variable x takes the value less than equal to -1.5, right?
Okay,
Only
so that will be -2.
it will remain 0.10 for all the values in between -1 and -2, right?
Yes, sir.
But as soon as I reach -1, it will again take a jump of 0.25, right?
Yes, sir. I got this. What do the dotted lines stand for?
It's just to show that it is discontinuous. Like firstly we were here, then after that we are straightly going to this point.
So they are not necessary.
Yeah, dotted lines are not necessary. You can skip those as well.
Okay, thank you, sir.
Okay, anyone, any doubt till now? We are done with the week 9 for now. Okay, let's move to week 10 then. Okay. So week 10. Okay, so for now we are like, we know what is random variable, what is random experiment firstly, how we define random variable for that experiment, and some possible values it can take. Okay, so let's suppose your random variable x can take some possible, like you perform some experiment. The possible values of random variable x can take, let's say, is 2, 3, 5, 7, 10. And you have some probability defined for each of these values, let us assume. Okay, so suppose I did it first. Let's say I keeps on repeating the experiment. Okay, so in the first experiment I got, let's say, 3. For second experiment, let's say I got 10. Third again I got 3. For this one I got 2. I got the 7. So if I keep on doing it, a large number of times, and if I take the average of all the possible, like all the outcomes which I got, like if I'm doing it 5 times, I will take average of these 5 numbers: 3, 10, 3, 2, and 7. If I keep on doing it 1,000 times, 10,000 times, I will take the average of all those values. So that average is called expected values. Yeah. In other words, expectation, right? What does expectation means? So expectation means that if you keep on performing the experiment again and again and again, and you note down the values of x.
So what was the word you were going to use in the first case? You were saying expect something.
Expected value.
Expected value, okay.
So if you keep on doing this experiment, take the average of all the values obtained, and then you will get the expected value of random variable x. Expected value is nothing but the average value of our random variable x.
Yeah, expectation is weighted mean. Yeah.
Yeah, it's the average in general. So if you keep on repeating it again and again, so you are expected to get an average of this value. So suppose we get the value of 6 over here. So it means the average of all this value would be somewhat close to 6 or something. Okay. So in practically, yeah, we want to performing the experiment like 10,000s of the times, right? So how do we compute the expectation? Okay. So to compute the expectation, it is kind of weighted mean, like someone mentioned. So suppose this is your PMF. Your x can take values, let's say 0, 1, and 2. Suppose. Okay. The random variable x can take the value. Let's say it's 0.49. Okay. 0.42. 0.09. So how do we compute the expectation? So for expectation, we use this formula. We are summing all over the range of x, where the value of x is multiplied by their respective probabilities and then added. So here if you see, firstly we have 0, right?
0.6.
So the chances of getting value 0 is 0.49. So it's kind of we are assigning weight to the value 0, that 0 has a chances of getting 0.49. Then next possible values is 1, right? So 1 times its probability plus 2 times 0.0. So if you compute it, it will come out to be 0.60. What it means is, if you keep on doing this experiment again and again and again, large number of time, and take the average of all the values obtained, your average will be more or less approximately 0.60. That's what your expected value is, and that's how you compute it. Is this clear, everyone? Or any doubt in it?
Sir, average means?
Average means like just the average of all the values you have obtained. We have performed the experiment 10,000 times, noted down the observations. If you take the mean of it, mean, you will get this value 0.60. So in general, we cannot have 10,000 times. We cannot perform experiment 10,000 times. So we can use this formula to obtain it. And even if you perform, if you are able to perform, you will note it that it will, the value you have obtained is close to this value. Okay.
So why are we calculating this expected values?
Why are we calculating this? Okay. Good question. Okay. So you remember that game of gambling, right? I will get ahead if I, let's say, get the +5, right? If I get ahead, I will gain $5. If I get tail, I will lose $3, right? So, okay. And let's say probability of head in each toss is 0.4. So will you play this game or not? So to decide this, you can use the expected value. So your random variable x can take values 10, 2, and -6, right? You know how will it take value 10, 2, and -6, or shall I compute again?
We are tossing 2 times. Huh?
Yeah, tossing 2 times. So you get
so 2 heads, 1 head. Yes, sir.
Okay. So you want to know whether by playing this game you will be benefited or not. So you try to find what is the expected value, or what is, if I keep on playing it for a long time, what will be my average gain, right? So we know that, okay, let's compute the probability. When will you gain that? The chances of you getting a $10 is 0.4 times 0.4, right?
0.16.
Chances of you gaining $2 is 0.48, right? Chances of you losing 6 is 0.3. So if you keep on playing this game for a very long time, so you are expected to win or lose. Let's see, 10 times 0.16, right? Plus 2 times 0.48 minus 6 times 0.36. It comes out to be 1.6 plus 0.96 minus 2.16. Come out to 2.56 minus 2.16. So you are expected to win $0.40 on an average. You keep on playing this game for a long time. So you can definitely play this game because it's gonna give you a profit, right? Let's modify this. Suppose the entry fee is $2.
Sir, just one question.
Yeah, just any doubt?
Sir,
Yeah.
Yes, sir. Sir, just one question. Here, $0.40 means here it is saying means we can say that I have 40% chance to win a amount.
No. It says that if you keep on playing this game, right? On an average, you can win $0.40.
On an average, I can win for $0.40.
Yeah. Like suppose in the first you won $10, right? Let's suppose in the second you lost 6. In the third you won 2. In the fourth you again lost 6. So you keep on playing it, let's say 1,000 times. So if you average your all this, you will notice that it's only 0.40.
But it will, sir, give the value of random variable, long run average.
Yeah. Is it clear? Everyone expected value?
Yes, sir.
Okay. So let's say I'm not, yeah. So we know expected value of x is, or now if this comes out to be 0.40, right? Let's modify the question a bit. Let's say you have an entry fee of $2. Like for each time you want to participate, you need to pay $2. So let's say this is your random variable y, which is nothing but your old random variable minus 2, right? Instead of $10, you will be winning only $8 because you have paid $2 as entry fee, right? Notice it. Head, tail, head, and tail. Right? So your x can take the value. $10 you are winning for 2 heads, right? $2 you are winning for head tail, 2 you are winning for tail head, and you're losing $6 for tail tail, right? Now your random variable y is your actual net gain.
80, 80 and minus 8.
Even though you are winning $10, you are still paying $2 as a participating fees. So you are headed, even if you win $10, your actual benefit is of $8 only. For head tail, it would be 0. For tail head, it would be 0. And it would be minus 8 for tail tail. Now, will you play this game? So if you compute the expected value of y,
there won't be any gain or loss. Exactly.
there would be, right? Okay. So how would you get the, what is the probability of head head? It was 0.16, right? Plus for head tail and tail head, it was, doesn't matter, it's actually gonna be multiplied by 0, so we can skip this. For minus 8, getting 2 times the probability was 0.36, right?
One doubt over here, when you say entry fee, it is only paid once when you are entering the game, right?
Every time you play.
Okay, then it makes sense. Yeah, thank you.
Okay, is this thing clear to everyone?
So how did we get 0.16 and 0.36 as probabilities?
First probability of head was 0.4.
Okay, yeah, right. I got you.
Probability of tail was 0.6. Okay. So now the expectation has some good properties which will easy your problem. Suppose you know the, let's say, PMF of x. Let's say it is something 2, 3, 5. Respective probabilities are, let's say, 0.25, 0.35, and 0.40. Okay. So you have computed the values, like you have computed the expected value of x. Now someone asks you to compute it for a function of x. Let's say the function of x is g of x. It could be any function. It could be either, let's say, 3x plus 2, or let's say someone says x square. I want, say, someone says I want, you can think of, let's say someone want x cube plus 4 I want. So how will you compute the expected value of this function? So it's again the same formula. Expected value of this function of x. Here you will add again over the range of possible values your function can take. Its value of function times the probability at your random variable x takes the value of x. Why this is? Okay, let's suppose we take this function x cube plus 4. Whenever x is 2, my function would be 12, right? When my x is 3, what would be my function?
31.
13.
31, right? And for x equals 5, my function would be
129.
129.
Okay. So here you notice when my function x will take the, but like when my defined function will take the value 12, when the value of my random variable x is 2, and it is 2 with probability 0.25, right? So in general, you can also define PMF for this function. So if you notice that your gx will take the value 12 whenever your random variable x is equal to, and when will x will equal to 2? With probability 0.25, right? Your function will take the value 31. When will it take 31? When your random variable x takes the value 3. It will take value 3 with probability 0.35. Similarly, for 129, it would be 0.40. So again, like you can denote gx by some another random variable y. So expected value of g of x, like any function of x.
How did I get this 12, 31, and 129?
My function is x cube plus 4.
Okay.
So I can write it as expected value of y, and again the same formula. You can apply over the range of y times probability. Very clear? Like given the PM of x, you can also compute the expected value, or you can also compute the PMF of any other function of x as well. Any doubt in this, or is it clear? Anyone? Is this clear?
Yes, sir.
Sir, how are questions framed around this concept?
We have enough questions in, I think, practice and graded assignment. Have you gone through that in week 10?
Yes, sir, some of them.
Yeah, so we have some similar question. When you go through it, you will get an idea like how we are using these concepts over there. Okay.
Okay.
This maybe the probability does not change, right? Only for value of function changes and does not affect probability.
Yeah, probability won't change even though values of function keeps on changing. Okay, yeah.
Sir, if we take expectation of x cube plus 4, by the expectation property, we can write it expectation of x cube plus 4. If we calculate the x cube value and after that we add 4, then the answer will be the same.
Yeah, then also answer will be the same.
Okay.
Yeah, it's coming to it. Yeah. Properties of expectation. Properties of expectation. So suppose you know the expectation of x. Okay. You know, let's say expectation of x is, let's say, is 4. And you have some linear function. Okay, so focus on the word linear function. Okay. So you have this linear function g of x is 3x plus 4. Now I ask you to compute expected value of this. So by the previous method, what you will do is you will obtain the PMF for this, then apply the expectation formula, and then you will get the value, right? It's gonna take a lot of time, at least more time than the method we are going to discuss now. So what the property of expectation says is, if you multiply your random variable by a constant a, let's say a and b are my constant, which are real numbers. Okay. I hope you are aware of these symbols by now if you have done maths 1. Okay. So if I multiply my random variable by a constant a and I add another constant b to it, then its expected value would be same as a times the expected value of x plus the constant b. So here in this question, if you see, I know expectation of x is equal to 4. To find this function, here you notice my a is equals to 3, right? And b is equals to 4. So expected value of 3x plus 4 would be same as same as 3 times expected value of x plus 4, which is nothing but 3 times 4 plus 4, which is 16. Whenever there is a linear function, remember linear function. Whenever it's not linear, suppose your function is like we did earlier, right? X cube, cubic function, or quadratic function. In that case, you won't be able to use this property here. But whenever you have linear function, you can directly use this property to compute. Is this clear, everyone? Or any doubt in this?
Why is that? It can be expectation of x cube plus 4, na, sir?
Yeah.
So we can use it.
But yeah, you still need to compute expectation of x cube, right?
Yeah, I mean, like we are still able to. Okay. Yeah, right.
Okay. Anyone, any doubt in this till now? Shall we proceed further? Yeah, okay. So now suppose okay, suppose you have 2 random variables, let's say x and y, and you know the expected value of both. Let's say expected value of x is 4, expected value of y is, let's say, 16. You want to find the combined expected value, like expected value of their sum, x plus y. By the property of expectation, you can also sum them individually. Okay, you will get the same one. So expected value of x plus y would be same as 4 plus 16. Okay, so that's just another property of expectation. Okay, clear?
The proof of this. Here, sir, X and Y should be independent.
No, not independent. Even if they are dependent, it will work. The proof of this involves the concept of multiple random variables, which we will cover in week 1 and 2 of stats 2. In the first 2 weeks, you will cover this. All these things will be covered along with the proofs. Okay.
Okay.
All these properties are for mean also, na? Normal mean, which we take two sets of, suppose we take two sets of numbers and we find the means.
Yeah.
Then these properties will apply to that mean also, those means also. No?
Those means also. Okay. No, those means it depends on number of observations you are taking. So yeah,
General number of observations.
but it will, you have to check. The number of observation plays a role over there. But here it's simple. You can simply add the two. Okay. Any doubt till now, anyone? Before we move to next topic. Okay, so moving further, we have hypergeometric random variable. You all know what is hypergeometric random variable? Anyone? Anyone of you know what is hypergeometric random variable?
Sir, if we have a sample of size n and if we are choosing some object from without replacement, then we can apply the hypergeometric random variable.
Yeah, good enough. Okay, so now suppose this is your complete population. Okay, so you have capital N elements in your population. This is your, let's say, population size. Okay, and let's say, okay, let's take it through a common, like this is the most common example you would ever heard for hypergeometric random variable. Consider this as a pool. Okay, so you have capital N fishes in it. Okay, of these capital N fishes, small m are red in color. Okay, and capital N remaining ones, capital N minus m are remaining ones, right? They are black in color. Okay, if I randomly draw one fish from it without replacement, right? I keep on doing it. I have drawn smaller number of fishes from it without putting them back in water. So that's my sample size, the number of fishes I have drawn without replacement. Then the number of red fishes I got. Okay. So if you notice, your random variable x can take value. Either you can have 0 red fishes, 1 red fishes, 2, or all n random, or all n red fishes, right? So you can compute probability for all of this 0, 1, 2, and you have to make cases and then solve. But luckily we have generalized formula for this. It is that it will take the value this. So it is mcx n minus m choose n minus x divided by n choose n. Okay, so how did we get this formula? So see, in total, the total number of cases is always in a denominator of probability, right? So in total, you can choose any small n number of fishes from those capital N, right? While coming to numerator, you should have x red fishes, right? So of those small m red fishes, you have chosen x red fishes. And from the remaining, you have chosen remaining n minus x black fishes. The simple probability we used to do in week 7-8. Is it clear? Where x can take value from 0, 1 to n.
So small n is less than m, right? small n is less than n.
Yes.
There are multiple conditions on it.
Yeah.
Let's not go into that for that. But yeah, there will be some condition when your small n will be greater than m, small n will be less than m. There would be
Yeah,
multiple.
it depends.
Yeah, it will affect your range, like the possible values of x. But let's now for assume the general case that it is possible to draw all in red fishes. Let's assume it is.
Is this related to Bernoulli's?
Is this
Related to Bernoulli's theorem?
no, not that. In that you will have with replacement, but here we are doing without replacement.
So, but here n has to be less than or equal to m, right? Otherwise, we will not be able to take n.
Yeah, let's assume for this. But in general, it is also possible for n to be greater than m. Okay. In general, it is possible. So that will affect your possible values of x. In general, it is possible, but yeah, it will affect your values of x. So in general, the range of x is a bit.
So it will be applicable even if n is greater than m. It will be applicable even if n is greater than m.
Yeah, it will be applicable.
Okay.
So, is this clear? If you remember week 7, that's how we used to do the question, right? If I need x of red color, I will choose x from these m. Remaining I will choose from other, and total number of ways I can draw is NCN. Like simple probability question we used to do in week 7, right?
Yes, sir.
So it's the same. So now let's next thing. What is the expected value of my random variable x? One way you can again compute the probabilities, apply the formula of expectation and perform. But luckily, whenever it's hypergeometric distribution, you can directly use the formula small n into small m by capital N. So in the question, whenever you see that, yeah, it is hypergeometric random variable, we are drawing something like we have population divided into two categories, category 1, category 2, and we are interested in the number of let's say elements in our sample belong to one specific categories, and we are drawing the sample without replacement. You should be able to identify it. Yeah, it is hypergeometric random variable. No need to compute probabilities, nothing. Just simply use the formula. It will save a lot of time. Only time you need to spend on is to identify that, yeah, whether it's hypergeometric or not.
There are only two variables.
Here we have.
There are only two variables in hypergeometric.
So, see, no, here.
Rephrasing the question, if I were to rephrase the question, let's
Okay.
say if there is a red, black, and say green.
Okay.
Okay. Would the same formula still hold nm by n?
Would the still okay? So you are if your random variable okay, but if what is your random variable x? Your random variable x is number of red balls.
Yeah.
Yeah, it will still hold. So your first category is red, okay, another would be non-red.
Okay.
I am still able to divide my complete population into two categories, right?
Okay.
And I am interested in number of elements in my sample from this category.
Okay.
Metric, right? So whenever
Okay.
just keep in mind the conditions. Whenever you are able to identify that it's hypergeometric, directly use the formula. Okay.
Thank you.
Anyone, any other doubt in this?
Sir?
Yeah.
Sir, how does the expectation work with this, sir? Like only one side we are considering it.
Only one?
Like we are considering only red or black, right?
No, my random variable x is the number of red balls. So I'm interested in number of red balls in my sample.
Okay. The experiment is number of red balls. Okay. All right.
Anyone, any other doubt in this before we proceed further?
How to identify things? Any algorithm specific?
No, you need to identify. See, this is my complete population, right? I know the number of elements in my population. Okay. I am able to divide my population into two categories. One is red colored, another is non-red colored. I am interested in how many elements in my sample are from this category of red color. And I'm drawing without replacement. So in that case, you are identifying that it's hypergeometric. Whenever these conditions are satisfied, it's hypergeometric. First condition is divide into 2. Second is it should be without replacement.
So will you be uploading a PDF of this, whatever you've written?
It's the whiteboard, not video, so I won't be able to upload.
Okay.
But it will be available on YouTube. You can go and you can write it in your notes. I think in a good handwriting at least. Yeah.
Okay.
Okay. Yeah. So these two conditions you should keep in mind, that you are able to divide your population into two categories, and then you are drawing the sample without replacement, and your random variable is number of elements of category of a specific category. It could be category 1 or it could be category 2.
Sir, one doubt here.
Yeah.
Sir, if three categories, red, blue, or green, then we are interested in red, then we can divide into two, red and one green and blue.
Yeah, one red and another non-red. I can still able to do, right? Red.
It can have many categories, not just two.
Yeah, suppose let's consider we have red color, okay, and we also have blue, we have yellow, black. I'm interested in red color, okay. So what I can do is, this is my category 1, okay. Remaining 3 I can combine in category 2, right? I'm still able to divide my population into two categories, category 1 and category 2.
Okay, sir, got it.
Okay, anyone, any doubt before we proceed further?
Sir, in extension to the same question, right now here you said red and other categories, right? All the 3 categories, where
Yeah.
X is my random variable for number of red balls.
Yeah.
So once I calculate expectation of this, and then similarly I'll calculate expectation of blue balls.
For blue, yeah, and you can take blue as one category and non-blue as others.
Yes, for exactly, sir. So in the same way, if I calculate expectation for all the 4 colors, and if I add them by extension of expectation properties,
yeah,
can I say the expectation of getting a red ball plus a blue ball plus an yellow ball plus a black ball is E of X plus Y plus Z plus W?
Yeah, you can do that. Yeah.
And will the same hold good for probability too?
Same probability. Yeah, for this, right?
Yes, yes, exactly.
Yeah, same hold true. Yeah.
Okay.
Thank you. Okay, let's move further. I think we have covered expectation, we have covered hypergeometric distribution. Let's move to the variance. So here we will be talking about variance of random variable. Do you all remember the variance from week 4? Like how we used to compute variance in week 3 and 4, we did it, right?
Sir, independent variables minus the average whole square.
Yeah. So what does variance tells you about the variable? What actually is the variance?
Variability.
Spread of the data.
Spread of the data, sir.
Spread of the data from which point? Variability around which point?
Mean, average.
From its mean.
About the mean.
Yeah. So variance tells you about how far like your other observation are from the mean, right? How much variability from the mean is there in your data. So it is possible for you to have same expected value for different random variables, but to know how much values are spread from that expected value, we need to compute the variance. Okay, So any one of you remember the formula for variance from week 3?
X minus mu whole square.
X minus X bar the whole square.
X minus X bar
the whole square divided by N.
Population.
Right? This one, right?
Yes, sir.
Let's say this term is y. Let's suppose for now, okay? So 1 upon n summation y. It is a mean of y in general. I'm
Yes, sir.
Mean of y. Okay. So mean is same as expected value, right? Right?
Yes, sir.
Let's move. Plug in the value of y. So what is your y? It is actually x minus mean of x, right? Whole squared. Clear?
Okay.
Yes, sir.
This is the formula for variance of random variable. Same thing. You have already done all this thing. You're not just doing it in terms of random variable.
We are converting the previous formula to this formula. It's easy now.
Clear how we got this formula for variance?
Yes, sir.
So in general, you can also open it. Okay, does anyone remember the expansion of this formula? Simplification.
Xi
minus nx bar.
This, right?
Yes, sir.
Let's say
nx bar.
No.
Nx bar, right?
No, not nx bar. 1 upon n is only with my first term.
Yeah, it gets to be nx bar minus 2x bar, which is 2nx bar. Yeah, something.
Okay, just go through that again. Okay. Just when we simplify this, you will obtain this. Okay, those who
Yeah. It's
through it and try. Okay, so let's say some xi square is z. Okay, let's say 1 upon n summation z. Mean of z, right? Right?
What is z here, sir, now?
That is xi square.
Okay.
So expectation of z, which is expectation of x square.
Right? Mean of z, right? Clear? Minus x bar is mean of x, right? Mean whole square, right? Expectation of z. Okay, plug in the value of z. What is z? X square, right?
X, right.
Another formula for variance, right? So when you simplify this, you will obtain this. And when you simplify this, you obtain this. So we have converted both the formulas in terms of random variable. Clear, everyone? Or any doubt in this?
Yes, sir. Clear.
Anyone, any doubt? Please ask.
Sir, in one of the lecture, ma'am told if the variance of random variable is 0, the cardinality of range of random variable is 1. What it means, sir?
Cardinality. Okay. Cardinality of. Okay. This thing is clear firstly before I move to that part.
Yes, sir.
Yes, sir.
Okay, great. Let me erase this right hand side. So especially remember the variance formula in the orange part. Proved to be pretty helpful as compared to the blue one. So yeah, no need to remember two different formula. You know how. See, we are only gonna do week 1 to 8 again in terms of random variable. That's all. We are doing nothing new. We are doing now in week 9 to 12. Okay. So what is range of random variable? What is range of random variable? Does anyone know? Suppose
minus infinity to infinity.
Maximum minus minimum.
Real numbers.
suppose my random variable x can take values
-1 to 1 to 1.
It is real number.
3, 5, and 7. These are the 4 values my random variable x can take. What is
5 and 5.
Anyone?
0 to n.
2, 3, 5,
The
7.
range is 5.
7 minus 2, 5.
5, sir.
Sir, range is 5.
X minus 1.
Okay. So
Range is 2. Range is 5. 7 minus 2.
Yes, sir. 5.
Maximum
Range is 5.
minus minimum.
Sir, what type of range is this?
this thing, remember in case of random variable especially, range of random variable is a set of all the values your random variable can take.
Okay.
Don't be confused with the term range in case of random variable. Range of random variable is the set of all the values that your random variable can take. Okay. So
here the range is 2, 3, 5, 7. All the numbers.
Range is this set 2, 3, 5, 7.
Sir, it can be negative also.
Yeah, if your s can take value -2, it will be -2, 3, 5, 7. All the values your random variable x can take is the range of the random variable. Okay. Yeah. So do you know what is cardinality?
The number of
elements in the set.
What if when is my cardinality 1? It means
there is only one element.
Only one possibility for random variable x.
Yes, sir.
Let's say it's 2. Okay. So whenever your random variable x takes the value, one single value, cardinality equals 1. Your variance of that random variable would be
0.
0.
Why so?
Because there's nothing to calculate about the spread of the data.
Yeah. So if you compute, your mean would also be 2, right?
Yeah.
Division only.
Mean
No,
and the value is m, so it's 0.
there is no deviation from the mean value, right? It's only 2. Only you have only that value in the data set. No value is deviating from the mean, right? So there is no variability, right?
Yes, sir.
We can also do it mathematically. If you plug in these value, compute expectation of x square, expectation of x, put it in, you will get 0. But why we will get 0 is you have only one value. Your mean would be that value only, right? And there is no other point which will vary from your mean value, right? So there will be no variability at all. No variability from mean, right? No spread from mean. It would be only
here probability is 1, no?
Yeah, probability is 1. Only one value it can take, it would be 1, right?
भाई के कहने पर मैं भीतर
we can also argue, sir, e of x minus ex the whole square is 0. Means that x minus e of hello.
Yeah.
Expectation of x minus ex the whole square is 0. Means that x minus ex has to be 0 because it's the sum of all squares. It's the mean of all squares. So it's the sum of all squares. Meaning that x minus ex is equal to 0 which means that x is equal to ex, which means that all the values are the expectation of x, means there is only one possibility for the
yeah, good enough. Yeah. Is this clear to everyone?
Yes, sir.
Shall we proceed further? Okay. So you all know now how to compute variance is some Bernoulli random variable. Okay. Does anyone know what is Bernoulli random variable?
There are only two possible outcomes, success and failure.
It can take only two values.
An equal chance of all the two variables happening.
Either a success or failure.
A random variable which take value 1 or 0.
Okay, before that, let us the properties of variance as well. So, do you remember the properties of expectation, right? We can simply add and do all things, right? Now, what if we have a function? Suppose we again have a function of x as ax plus b. We know expectation. Okay, let's make it constants. Let's make it 3x plus 4. We had expectation of x as 4. So we were able to compute the expected value of gx, right? By using the property of expectations. So it comes out to be 16. Now we also know that variance of x is, let's say, 2. How will we compute the variance of this function? One way is simple. Obtain the PMF of gx, right? And then you can simply compute the variance using the formula, right? Another simple way. How does variance gets affected? So if I multiply my random variable by a constant a and add another constant b to it, such that my both a and b are obviously real numbers only. So your variance would be constant squared, this a squared times variance of x plus, okay, nothing plus, it don't get affected by addition. This thing also you have covered in week 3 already, right? If you multiply your variance by your variable by a constant, your variance become constant squared times, right?
Yes, sir.
This thing we also covered in week 3, 4, but in terms of random variable, it is like that. If you know variance of x, then variance of ax plus b would be a squared times variance of x. Addition of a constant does not affect your variance at all. Only multiplication and division affect. Okay. So if we know variance of x is 2 and we need to compute the variance of 3x plus 4, it would be nothing but 3 squared times variance of x, which is
9 into variance of x.
Is it clear, everyone? Or any doubt in this? Anyone, any doubt? Or is it clear?
Yes.
Just one question about that expectation. Sum of expectations is sum of the variables is equal to sum of the expectation. Expectation of sum of the variables is equal to sum of the expectations.
Yeah.
So this property is similar to the property for average, which was covered in the first 4 weeks.
Yeah.
Suppose if we take the equal number of observations in both the for both the variables, if we take equal number of observations for both the variables, then this property will hold true for that average also, no? That mean also, no?
Yeah, it will hold true. Everything you can link with week 1 to it. Everything you study in week 9 to 12. It's nothing new.
But suppose the number of observations are different, then it may not be. Then of course we can. Then of course we cannot add the two variables, because in one the observation is number of observations is different, and in the second the number of observations is also is different. So we cannot add the two variables to find the expectation of the sum.
Yeah. So yeah, there would be some factor, but yeah, it would be possible to obtain the value by doing some multiplication, addition stuff, by manipulating a bit. But yeah, you can still obtain. Okay. Next. Okay. So yeah, we are talking about addition of variables, right? So we know expectation of x plus y is equals to expectation of x
Plus expectation of y.
This is always for all variables x and y. What about variance?
They should be independent of each other.
Yeah, great. It will only be true if and only if x and y are independent random variable.
Sir, example.
Okay, let's say your one random variable is x, okay, and another one is also x. Like x won't be definitely independent of itself, right? These two will be dependent. So according to you, if I do variance of x plus x, it should come out to be variance of x plus variance of x, which is 2 times variance of x, right? But in general, what it should be is variance of 2x, which is 4 times variance of x, right? For dependent variables, this condition won't hold true. It will only true if and if your random variables are independent. Any
But
doubt?
if y equal to 2x,
If y
then
equals,
it is also dependent.
yeah, if y equals 2x, then also it will be dependent, right? Any random variable would be dependent of itself.
Sir, instead of independent, it is given that it is mutually exclusive, then what will?
Instead of independent,
If it is given that they are mutually exclusive, then what will?
mutually exclusive means disjoint. So no, they should be independent for this property to hold true. Otherwise, it won't hold true in any other condition.
In disjoint as well, they are independent.
No, disjoint, either they will be disjoint or independent. They cannot be both at the same time. Okay. No two disjoint events can be independent. Because for independence, you must have this thing, right? While for disjoint events, you have this thing. So if they are disjoint, they cannot be independent. And if they are independent, they won't be disjoint. Something like that.
Sir,
Anyone?
class
Yeah.
now, sir.
Can you repeat?
We have a CT class now, sir. CT class.
Okay, we have just. Okay, Bernoulli random variable, I think you will cover in week 11 as well. Okay, yeah, I think we can start from that in the next revision session of week 11, 12.
Sir, I had a doubt. I told you like before.
Yeah, those who have doubt can stay.
Thank you, sir.
Thank you, sir.
Yeah, one feedback before you all leave. How is the practice book for week 7 to week 12? Helpful for preparation, or what's your review on it?
Yes, sir. It's very helpful.
It's good, sir.
So those who haven't
Sir,
read,
where is the practice book?
Supplementary content.
Okay, thank you.
yeah, we have seen the as well as the supplementary content. Go to practice books. There you will see week 0 textbook. So it is for week 7 to week 12 content of statistics 1. It may have some extra contents because specifically it's for statistics 2 week 0 content. But yeah, it has same week 7 to week 12 covered. Okay.
Sir, also is week 1 to 8 revision over, sir?
No, this time we will be having only week 9 to 12. Week 1 to 8 we have already did this term, right?
Okay. Is the recording available, sir?
Yeah, it's available on the YouTube.
Okay, sure, sir. Thank you, sir.
Thank you, sir.
Thank you. Okay, so
Thank you,
those
sir.
please stay and ask.
Sir, will you take anything from week 1?
Can you repeat?
Will you take any questions from week 1?
Yeah, you can ask.
So how to find the CDF from a PDF?
Sir, can you like clarify those two questions which I had a doubt in week 9 first?
So for CDF to PDF, you basically differentiate that function. That's all, nothing else.
But the question is 12 activity 12.1a question number 2.
Sir, can you answer my two questions from week 9?
Yeah, just a minute. After that, I will move to your activity 12.1, right? Question number
12.1a question number 2.
Question number 2. So you have to identify.
No, actually the question is question number 5.
Question number 5, right? So there you have to obtain from PDF, you need to obtain the CDF.
Yes.
So your PDF, it's 1/4, right? Or 0.25 in the range -1 to 3, right?
Yeah.
Okay. So do you know the? Okay. So what would be the PDF? It is uniformly distributed, right?
Right.
So what would be the CDF of uniform distribution? X minus A, right? Upon B minus A. Right? So here you are directly using the formula for CDF of uniform distribution. When we have to move from CDF to PDF back, we differentiate it. So if you differentiate it with respect to X, I'm assuming you are aware of differentiation from Maths 1. So you obtain the PDF. If you differentiate it, you will again get 1/4.
Answer if a PDF is given, how do we find the exact probability? I asked you this doubt today itself in the discourse, and you replied also.
Which one?
12.2 question number 1. But
12.2 question number 1. Okay.
Yes. Like 50 and 52 is given. And we need to find the probability the lecture length is more.
Uniformly distributed, right?
Yes.
So in general, you need to find probability X greater than 51, right? I can write it as 1 minus probability X less than equal to 51, right?
Yes.
And I know the formula for CDF of uniform distribution. I know X follows uniform 50 to 52, right? I think you should go through the lectures of week 12 again if you are struggling with these questions.
Yeah.
Okay, so who was asking from week 9? 2 questions.
Yeah, me, sir.
Yeah, which question?
Yeah, there's one particular practice assignment question.
Okay. Which practice question?
It's like wait a second.
Yeah.
Like the question is like which of the following are or is probability mass functions, and 4 are given, and I wasn't able to understand like how they were like going about proving in the solution. I couldn't understand that.
You 4 options is given in the form of graph or what?
In the form of equations. EMF equations.
EMF tables, right? So you have to check the properties is satisfied. Okay. Let me share my screen. Hope I get that question. This one. Question number 3.
It's 4th question, sir. Yeah, that one.
This one. Okay.
Yeah. I can't understand the answer for this.
Okay, how did you approach this one?
I like I could understand like when they were like making the geometric progression, they were using it to find the sum of it, but in somewhere between in the answer they were like dividing it into. I couldn't understand the logic behind it. I mean, like I couldn't make sense of it. I mean, like it was like feeling wrong to me. I didn't understand that part.
Have you tried it on your own?
No, I couldn't do it on my own, so I just directly went for the answer which was given below. That's what I couldn't understand.
Yes, at least you should, I think, try once, right? And try to do at least once. Okay, one part I will do. Which part you want me to do?
Actually, if you can just click on submit and the solution appears, you can explain the solution right away.
Okay, but I want to explain the full. At least you should try to do once. Looking at the solution and doing won't gonna help you in any way.
Wait a second. I mean, like, can you just scroll down? Yeah, this option B. Explain me option B.
Option B.
Yeah.
Okay. But option B. It's 1/8 times x plus 1, right? This thing, right? And
Yeah,
x
exactly.
value from 0, 1, 2, so on.
Yeah.
1/8 I can take common. When my x takes value 0, it would be 1, right? X takes the value 3, it would 2, it would be 3/2 squared, right? For x equals 3, it would be 4/2 cube, right?
Yeah.
We're doing it right, huh? So 0. Okay, so we have missed the 1. Okay. For x equal to 0, we got 1. For x equals to 1, we got
1. Yeah, 1 is 2/2, right?
3/2 squared, 4/2 cube, right?
Yeah.
So I can assume it to be my S, this complete term. Let's say it is S, okay?
Yeah.
Your S is, have you done AGP?
Yeah. It's AGP. I didn't get it.
Combination of AP and GP.
No, I haven't done that.
Okay, so it is an AGP. See, you notice that here the common ratio is 1/2 in terms of GP, right?
Yeah.
But in terms of AP, it's also an AP from the numerator point of view, 2, 3, 4.
Yeah. 1 and natural numbers.
Yeah, so it's AGP, we say. So what we do is, what is the common ratio? 1/2, right?
Yeah.
We subtract 1/2 times this. Okay. So 1 into 1/2 would be minus 1/2.
Yeah.
2/2 into minus 1/2 would be minus 2/2 squared.
Yeah.
3/2 squared into minus 1/2 would be minus.
Will be again 1 minus 1/2, the second term.
So if I do it in LHS, I would have 1/2 S, right? In RHS, I would get 1 plus 1/2 plus 1/2 square plus 1/2 cube, right?
I didn't get like what I didn't get that minus 1/2 into S and 1/2 into S. You divided it. I didn't get that.
No, this is S, right?
Yeah.
I subtracted 1/2 S from this.
Okay.
This term comes as it is. 2/2 minus 1/2, we get 1/2.
Yeah.
3/2 square minus 2/2 square, we get 1/2 squared.
Okay. Yeah, now we can do the GP for it, like 1/1 by NSR.
Yeah, so 1/2 times S would be
1/1 minus 1/2, which is 1/2, which is 2. Yeah.
Equals
S is 2. Yeah, S is 4. Okay.
one by 8 into S 4 by 8. Yeah. Okay.
Okay. S is 2. That's the answer.
It's not adding up to 1, right? So it should not be a EMF, I think.
No, I mean something. It is given S is 2 somewhat something at the end. I don't know.
See, it's
Like
not.
S is 2. Yeah, S is 2 is given. Then again down substituting the above equation something.
No, forget about the solution. You understood what I did, right?
Yeah, yeah.
Okay, just try to do all the 4 options on your own now. Okay.
Okay, sir. And
Sir, last question.
graded assignment, ninth graded assignment, second question. Yeah, I couldn't even understand the question. I didn't even attempt it. All others I have attended, but that I didn't understand it. And I referred to the solution document as well. Even that I couldn't make sense of because I couldn't make sense of the question in the first place.
Okay. Okay, so see, but the question is that there is some lucky draw, the gambling thing we did today, right? For heads.
Yeah.
Okay. So entry price is $4, right?
Okay, so entry price is $4.
$4. You if you purchase a ticket, you need to pay $4, right? Because tickets are
Okay, so one ticket is $4. That means, right?
$4 each, right? It means each ticket is a $4, right?
Yeah.
Each has an equal chance of winning. Okay, any ticket can be the winner, right?
Okay.
So 2 tickets will win $267.
Yeah, what does that mean exactly?
Out
These
of
tickets
1,000,
will win.
only there will be only 2 tickets which can win $267.
Out of the 1,000.
Yeah, we randomly draw the ticket, right? We draw 2 tickets.
Okay, so we choose 2 among the 1,000 and they will win $267.
Yeah, so what is the chances of someone winning $267 is 2 by 1,000, right?
Okay, yeah.
Similarly, someone winning $163 is 8 by 1,000, right?
Yeah.
Favorable are 8, total are 1,000 ticket, right? Someone winning $40, 13, right?
13 by 1,000.
But remember, you're also paying $4 for the purchasing. So instead
Yeah.
of 67, you are winning 263 only.
Yeah.
Instead of 163, you are winning 159 only. So your random variable takes value 263, 159, and 36 with probability 2 by 1,000, 8 by 1,000, 13 by 1,000. And for remaining tickets, the value would be -4. You haven't won anything. You lost $4, right?
Okay, yeah.
Now you can compute the probability at your random variable x takes value less than something. Same example, similar example we did today, not same, right?
Okay, I'll try it once again, sir. Thanks.
Sir, activity question 9.5.
9.5, okay.
Question number 5. Question number 1.
Question number 1. Okay. There are 3 red and 7 blue balls in a bag. 3 balls are drawn one by one with replacement. Okay. Number of red balls. Okay. So what's the problem in this? Where did you struggle?
Right, 2020. Sir, in
total, there are 10 balls, right?
Yes, sir.
What are the chances of drawing a red ball? 3 by 10, right? In the first draw. 3 favorable cases out of total 10, right? In the second draw, it's again 3 by 10. In the third draw, it's again 3 by 10. So for all 3 red balls, it would be 27 by 1,000, right?
Yes.
Clear, right? Or any doubt?
And sir, for 2 red and 1 blue one.
Yeah, for 2 red, 1 blue, you need to make that. You need to consider that blue is drawn at the first trial, blue is drawn at the second, blue is drawn at the third.
So position matters.
Yeah, position matters. Yeah. Okay.
So, so activity 12.3 question 5.
Activity 12.3 question-5. Okay.
I need to get the explanation of the graph because fx is not clear what we do.
How did you approach this one?
Sir, depending on the parts, first of all, I divided it into 3 parts. From the
Okay.
From the graph, I just drew it in my copy and I found that the value, the point is lying between 10 and 12. So
No,
I
it's on 12.
No, it was not exactly 12. If you just enlarge it.
It is exactly 12. I'm telling you. It is 12 and it is 16.
Okay. Because in my screen, when I enlarged it, it came between 10 and 12. So I assumed it to be 11.
Because it would be given exact, but yeah, it is 12 for this and 16 for this. Okay.
Okay. But approach is correct. We have to draw it into 2 triangles and one triangle in between.
Yeah.
And height is not given, so I assumed it to be h. And
Yeah.
And by computing probabilities, h got cancelled and I got lost.
Yeah. Okay.
Practice assignment 9.
Okay, which question?
The last 6 and 7.
6 and 7. Okay. How did you approach this one?
I couldn't get.
Okay, I will explain the question in that case. Okay, so you are playing a book cricket game, okay, in general. So what happens in this is you suppose you have some book with lot of pages in it, okay. Close the book and you randomly opens a page, okay, and on the right side you will always have even numbers on the book if you notice, okay. So either you could have even number ending with 0. So if you get 2, 4, 6 or 8, that would be your score. If you get even number ending with 4, your score will be 4 runs, okay. But if you get 0, you will be considered out. So in general, you can have maximum of 5 chances. If you get out in the first chance, you cannot play your remaining chances, okay.
Yes.
Maximum chances you can play is 5. So what is the probability that Ramesh will be not out at the end of 5 chances?
Then 2, 4, yes, 6, yeah, 8.
Yeah.
First 5 chances.
Yeah. So that is our favorable cases, right? In the first chance, he should get any of those 4, 2, 4, 6 or 8, right? In the second also, third also, fourth also, fifth also. That's our favorable cases, right?
Yeah.
But what about total number of cases? For total number of cases, it is possible that you get out on the first chance, right?
Yeah.
It is possible if you get only 0 in the first chance, right? So only one way. Now possible to you get out in the second chance. It means in the first chance you get any of the 4, 2, 4, 6 or 8, right? And in the second chance you got 0, you got out 4 ways, right?
Yes.
Similarly for third, it would be 4 into 4 into 1, right?
Yes.
One, similarly 5 chances. It is possible that you remain not out, right? These are the total number of ways you can play.
But this is a problem. I can get total number of cases.
Now is it clear?
Yes, sir.
Okay, guys. Thank you, everyone.
Sir, one last question, sir.
Yeah, please.
Sir, in the lecture video, sir.
Yeah.
At the second PMF video, sir. Properties of PMF.
Okay.
The 28 minutes, 4 seconds, sir.
This one, right?
Yes, sir. Properties of PMF. Not. Yes, same, sir. In this 28 minutes, 4 seconds, sir.
Okay.
Yes, sir. Here, let y is a random variable which counts the toss in which the head appears first.
Yeah.
For number 2, it should be 4 by 8, no, sir, because we have.
No.
But Madam chose it's only 2 by 8. That means we will have head in the second place.
First head in the second place.
First head in the second place.
X is the variable which counts. Head
If we have 3 heads, sir, then it is also meaning. It's also assumed that we have a first head in the second place, no, sir.
No,
For
no.
3 heads.
First head is at first place only, right? First time you get heads in the first place in case of HHH, right?
Okay.
In case of HHT, again you got first head at the first place only, right?
Yes, sir.
In case of THT, you got your first head at the second place. In case of THS, you got your first head. We're talking about only first head.
First head, but it should be in the second place.
Yeah. So only possible outcomes are THH, TH.
Yeah, ma'am mentioned that THH and THT. Okay, so the head should be in the second place. It's count of the place also. Okay, sir. Okay, thank you, sir.
Okay. Thank you, everyone.
Thank you, sir.
Thank you, sir.